January 6th, 1610. The sun sets over Padua around 5 in the afternoon. In a cramped workshop on a second floor above the street, a 45-year-old mathematician stands at a grinding wheel, his fingers covered in Tripoli powder and glass dust. Galileo Galilei has been professor here for 18 years. He earns 520 florins a year now, triple what he made at Pisa. But it is never enough. His father died in 1591, leaving debts. He supports his mother, his younger brother Michelangelo, and 2 sisters who need dowries. He never married Marina Gamba, the Venetian woman who gave him 3 children, because marriage would drain what little money he has. His daughters Virginia and Livia, now 9 and 8, will end up in the convent of San Matteo because illegitimate girls cannot marry well. His son Vincenzo is 3. Lens blanks lean against the wall, some cracked, most useless. Since late November 1609, he has ground over 60 objective lenses. Only a handful work. He tests each one by aiming it at a chimney across the Piazza delle Erbe, then at the Campanile 2 streets over. Most produce blurred halos. Some show double images. He throws them into a wooden crate under the bench. His assistant Marcantonio Mazzoleni, the instrument maker who lives downstairs and manufactures Galileo's military compasses for pay, watches him work, but says nothing. The room is cold. Padua in January bites. But he lied. He told them he invented it. He did not. A Dutchman named Jan Lippershey tried to patent a 3-power spyglass in 1608. Word reached Venice by May 1609 through Galileo's friend Paolo Sarpi, a mathematician and consultor to the Venetian government. Galileo heard the rumor, bought lenses from spectacle shops, and within a day built his own 3-power version. Then he learned to grind. He improved it to 4-power. Then 9, then 20. It's the best way to support our work. Also comment from which city you're hearing this from. This script is researched and factual, using sources from NASA's Historical Archives published January 8, 2025, the Museo Galileo catalog of Galileo's surviving telescopes, with specifications confirmed by Paul Needham's exhaustive 2010 analysis in Galileo Makes a Book, and Stillman Drake's translated excerpts from Galileo's notebooks, archived at the Biblioteca Nazionale in Florence. Now back to the information. Marius will later claim he observed Jupiter's moons on December 29, 1609, using the Julian calendar, which converts to January 8, 1610, on the Gregorian calendar Galileo uses, one day after Galileo's first written record. Galileo does not know this yet, but he senses the race. Whoever publishes first owns the discovery. For 5 weeks, from November 30th to December 18th, 1609, he observed lunar phases through his 20-power telescope. He saw mountains, he saw valleys. He saw shadows moving across a terminator that proved the moon was not a smooth Aristotelian sphere, but a rough world with peaks 4 miles high, calculated from shadow lengths. He made watercolor sketches. He planned engravings. The discovery would demolish 2,000 years of celestial perfection doctrine, the idea that heavens are made of quintessence, unchanging and flawless. But moons do not pay bills. Books do. That is 9 days from now. Tonight, on the 6th, he does not know this decision is coming. He is grinding lens number 47. The convex objective is 1.7 inches in diameter, 37 millimeters, cut from German spectacle glass. The focal length needs to hit 980 millimeters. He stops the aperture down to 15 millimeters with a cardboard ring to reduce distortion at the edges, where the curvature bends light into halos. The concave eyepiece, 22 millimeters, must focus 475 millimeters behind the objective to give 20.6 times magnification. The math is simple. Divide objective focal length by eyepiece focal length. 980 divided by 47.5 equals 20.6. But the execution is brutal. Convex glass grinds fast. Concave glass chips. He learned this from spectacle makers in Venice, craftsmen who grind reading lenses for the far-sighted and concave lenses for the near-sighted. But those lenses focus at arm's length. Galileo's lenses focus at infinity. The curve must be shallower, the radius longer. A single speck of dust, a single uneven stroke ruins the lens. He works by candlelight, his eyes burn. Because the Medici family likes beautiful things. Cosimo II de' Medici became Grand Duke of Tuscany in 1609 at age 19. Galileo tutored him in mathematics during summers in 1605 and 1606. Cosimo now rules Florence. Galileo wants out of Padua. He wants a position with no teaching, full pay, and time to research. He will dedicate his findings to Cosimo. He will name whatever he finds after the Medici family. The stars, the moons, whatever appears in the glass. Flattery is currency. He slides it into the wooden housing at the far end of the tube. He inserts the eyepiece at the near end. He He carries the telescope to the window. The sky is clear. Cold air pours through the gaps in the shutters. He aims at the campanile. The bricks snap into focus. He swings to a chimney, sharp. He tilts up. The moon is nearly full, past third quarter, rising in the east. He sees the dark plain he calls the Mare Imbrium, the Sea of Rains. He sees the bright ray crater he will later sketch as Tycho. The Terminator is almost gone, just a thin arc of shadow near the western edge. No new mountains tonight. He has already drawn this phase. He proves the Milky Way is not a glowing cloud, but thousands of faint stars packed together. He moves west. He sees Taurus. He keeps moving. He stops at a bright point above Orion, Jupiter. The planet is brilliant white with a slight bluish tint, magnitude minus 2.5. It sits in Taurus near the stars of the Hyades cluster. He has not looked at Jupiter seriously before. Planets move, stars do not. Planets are predictable, boring. He almost moves on. To see anything, he must aim carefully and hold the tube steady. He leans the tube against the window frame. He closes one eye. He adjusts focus by sliding the eyepiece tube in and out. Jupiter swells. He sees the disk, not a point. A disk. Pale bands? Maybe, hard to tell. The image shakes with every breath. Then he sees something else. 3 small points of light. 2 to the east of Jupiter, 1 to the west, all in a straight line, all close, all bright enough to catch his attention, but faint enough that he's never noticed them before. Fixed background stars that happen to line up with Jupiter tonight. It is not unusual. Planets pass stars all the time. But something bothers him. They are too bright, too perfectly aligned. Too close? He marks their positions in his mind. East star, middle star near Jupiter, west star. He watches for 10 minutes. They do not move. He writes nothing. He does not realize this moment will change his life. He goes to bed. His lectures cover Euclid's geometry and Ptolemaic astronomy, the Earth-centered model he privately rejects, but must teach to medical students who need astrology for their practice. He is bored. He thinks about Copernicus. Nicholas Copernicus published De Revolutionibus Orbium Celestium in 1543, 67 years ago, arguing the sun is the center and Earth is a moving planet. The book circulates, but the Church tolerates it as mathematical hypothesis, not physical truth. Galileo believes it is true. He has no proof. If Earth moves, why does the moon stay with us? If Earth orbits the sun, why do we see no stellar parallax, no shift in star positions across 6 months? The stars must be unimaginably distant, or the theory is wrong. Padua is cold and damp. He thinks about those 3 stars near Jupiter. Afternoon. He eats bread and cheese. He drinks wine. He reviews his notes on the moon. He sketches a diagram for the engraver. He will need copperplate illustrations for the book. Copper holds fine lines. The printer in Venice, Tommaso Baglioni, can do it fast. Galileo estimates the book will be 60 pages, small quarto format, cheap to print. He will call it Sidereus Nuncius, starry messenger. Not sidereal messenger, even though that is the common translation. Nuncius means message, not messenger. He is reporting news. He's not presenting himself as a divine ambassador. The title matters. He adjusts focus. He sees Jupiter's disk. He looks for the 3 stars. They are there. But something is wrong. Their positions have changed. Last night, 2 stars were east, 1 west. Tonight, all 3 are west of Jupiter. West. How is that possible? If they were fixed stars, they should appear east of Jupiter tonight, because Jupiter moves eastward against the background stars at roughly 13 arc minutes per day. Instead, they moved with Jupiter, or Jupiter moved past them. He stares. He rechecks his memory. He is certain of last night's configuration. East, east, west. Tonight, west, west, west. 3 dots to the west. He labels east as Ori, Orient, west as OCC, Occident. He watches for 2 hours. The stars do not move relative to Jupiter. He is confused, but not alarmed. Planets do strange things. Maybe Jupiter moved faster than he thought. Maybe the stars are closer than usual. Maybe his memory is wrong. He goes inside. This script is researched and factual, using sources from Galileo's own manuscript notes archived in the Biblioteca Nazionale, published in Stillman Drake's Galileo at Work in 1978, and Albert Van Helden's translation of Sidereus Nuncius from the University of Chicago Press in 1989. Now back to the information. Johannes Kepler published Astronomia Nova in 1609, the same year Galileo built his telescope. Kepler proved planets move in ellipses, not circles. He calculated Mars's orbit using Tycho Brahe's data. Kepler is brilliant, but believes in mystical harmonies. Galileo respects his math, but not his astrology. Still, Kepler would understand. Galileo does not write, not yet. One is missing. He scans east, nothing. He scans west, 2 stars, both west of Jupiter. Where is the third? He checks his notes. 3 stars on the 7th, 2 stars on the 10th. 1 disappeared. How does a fixed star disappear? It does not, unless it went behind Jupiter, unless it is not a star. His mind races. If these points of light are not stars, what are they? Comets do not move that fast. Nebulae do not move at all. Planets are accounted for. Venus, Mercury, Mars, Saturn, all visible, all tracked. These are something else, something new, something orbiting Jupiter. He does not write this down, not yet. He needs more nights. But the idea is forming. Jupiter has companions, satellites, moons, just like Earth has the moon. If Jupiter can carry moons while it moves, then Earth can carry its moon while it moves. The Copernican objection collapses. Earth is not unique. Earth is not the center. The heavens are more complex than Aristotle imagined. He stares. He draws. He labels. Occident, 2 stars. Orient, 2 stars. He times their distances from Jupiter using the telescope's field of view. Rough estimates. 1 star is 10 arc minutes from Jupiter. Another is 8. Precision is hard. The image shakes. His hands are cold. But the pattern is clear. These are not fixed stars. They are moving around Jupiter. Inner moons move faster. Outer moons move slower. He does not yet know Kepler's third law, which relates orbital period to distance, but he senses the relationship. He needs more data. Weeks of data. Months. He will publish before he has it. He must. He observes Jupiter again. For the first time, he sees all 4 at once. 4 distinct points. 3 west, 1 east. He marks their positions precisely. He measures angular distances using the telescope's field of view and his knowledge of Jupiter's size. Jupiter's angular diameter is roughly 45 arcseconds at this distance. The moons are spread over 10 arc minutes, or 600 arcseconds, 13 times Jupiter's diameter. He writes, concluded these must be planetary bodies orbiting Jupiter, not stars, cannot be stars. He is certain now. He does not sleep. He returns to the desk and writes a letter, not to Kepler, to the Grand Duke's secretary. He does not mention Jupiter yet. He is not ready. He mentions the moon. He mentions the Milky Way. He says he has discoveries that will bring glory to Florence. He seals the letter. He will send it in the morning. He knows what he must do now. Publish, fast, before Marius, before Harriet, before someone else with a better telescope sees what he sees. He notes which moons are closer, which are farther. He begins to see patterns. One moon moves fast, completing an orbit in under 2 days. Another moves slower. He cannot yet distinguish which is which, but he knows he is watching an entire system, a miniature solar system around Jupiter. This is the evidence Copernicus needed. This is the proof that not everything orbits Earth. Galileo feels the weight of it. This is not just a discovery. This is a weapon against Aristotle, against Ptolemy, against 2,000 years of doctrine. He decides. He will publish. He writes to the printer, Tommaso Baglioni, in Venice. He tells him to prepare. He estimates 2 months for drafting, engraving, and printing. He's wrong. It will take less. He works every night now. He observes Jupiter. He draws diagrams. He sketches star fields. He refines his drawings of the moon. He writes in Latin, the language of scholars, fast and direct. No flowery prose, just observations. On the 7th day of January, in the first hour of the night, I saw 3 stars near Jupiter. On the 10th, only 2. On the 13th, 4. Cold facts. Dates, numbers, positions. He realizes the moon's eclipse passing behind Jupiter or into its shadow. He sees one moon disappear and reappear. He times it. He measures. He does not yet have names for them. He calls them Medicean stars in honor of Cosimo II and his 3 brothers, Francesco, Carlo, and Lorenzo. 4 brothers, 4 moons. Perfect symmetry, perfect flattery. The printing begins on January 30th, 1610. While he is still observing, the book is being set. The printer uses movable type, but the process is slow. Each letter is placed by hand. Each page is proofed. The copperplate engravings take longer. Galileo sends sketches to the engraver. The engraver cuts the images into copper plates, the moon's mountains and craters, the star fields of Orion and the Pleiades, the diagrams of Jupiter's moons, night by night. Galileo corrects proofs while observing new data. He adds observations from February. He adds observations from early March. The book keeps growing. The title page reads, Siderius Nuncius Magna Longeque Admirabilia Spectacula Pandens, starry message, revealing great and remarkable sights. The dedication is to Cosimo II de' Medici, Grand Duke of Tuscany. The book describes the moon's rough surface. It describes the countless stars of the Milky Way. It describes the 4 moons of Jupiter, tracked night by night from January 7th to March 2nd. 30 diagrams show their positions. It is the first scientific book based on telescopic observations. It is a revolution wrapped in 60 pages. 30 copies are printed on fine paper from the Fabriano mill, thick and bright, intended as gifts. Galileo signs some by hand. He sends one to Cosimo. He sends one to the Venetian Senate. He sends one to Kepler. He sends telescopes with some copies so recipients can verify the observations themselves. Verification is critical. Many will not believe. Martin Horkey, an astronomer in Bohemia and secretary to Giovanni Antonio Magini, publishes a pamphlet calling Galileo's observations the result of poor lenses and personal ambition. Horkey claims the moons are optical illusions, but Kepler supports Galileo. In April 1610, Kepler publishes an open letter endorsing Galileo's credibility. Later, in August 1610, Kepler observes Jupiter himself with a borrowed telescope. He sees the moons. He confirms Galileo's discovery. Verification complete. It reaches Paris. It reaches London. Scholars read it. Artists respond. Adam Elsheimer paints the flight into Egypt with a realistic Milky Way made of stars. Lodovico Cigoli paints Assumption of the Virgin with a moon covered in mountains and craters. The Church does not immediately condemn it. Pope Paul V receives Galileo in a private audience in May 1610. The Jesuit astronomers at the Roman College verify the observations in April 1611. They host a ceremony to honor Galileo. The Church is cautious but not hostile, not yet. The conflict will come later, in 1616, when Galileo is ordered not to teach Copernican theory, and in 1633, when he is tried by the Inquisition and sentenced to house arrest for the rest of his life. But on this night, January 6th, 1610, Galileo knows none of this. He is 45 years old. He is grinding lenses in a freezing workshop in Padua. He is in debt. He is exhausted. He does not know that tomorrow night, January 7th, he will aim his telescope at Jupiter and see 3 stars that will change his life. He does not know that by January 15th, he will realize they are not stars. He does not know that by March, he will publish the most important astronomy book of the century. He does not know that Simon Marius will claim priority and lose. He does not know that Thomas Harriot observed the moon first, but never published. He does not know that his observations will break the Ptolemaic system and support Copernicus. He does not know that the Church will turn on him. He does not know that 4 centuries later a spacecraft named Galileo will orbit Jupiter and study those moons in detail from 1995 to 2003. He has a former student who is now a Grand Duke. He has rivals. He has time, but not much. He finishes lens number 47. He tests it. It works. He mounts it in the tube. He closes the workshop. He eats a small dinner. He sleeps poorly. Tomorrow is January 7th. The night of January 7th, 1610, arrives cold and clear. Galileo carries his telescope to the balcony. The sky is black, no moon yet. Jupiter rises in the east above the rooftops of Padua. He finds it. He adjusts focus. He sees the disk. He looks for stars nearby. He sees 3, 2 east, 1 west. He does not yet understand. He thinks they are fixed stars. He makes a note. He draws a diagram. He watches for an hour. They do not move relative to Jupiter. He goes inside. He does not know this is the moment. He does not know this is the first recorded observation of moons orbiting another planet. He does not know this is the beginning of modern astronomy. On January 7th, 1610, at approximately 1 hour after sunset, which is roughly 6 o'clock in the evening Padua time, Galileo Galilei first observed what we now call Io, Europa, Ganymede, and Callisto, the Galilean moons of Jupiter. He saw only 3 that night. Io and Europa were too close together to resolve as separate points, but he saw enough. Over the next 2 months, he will observe them nearly every clear night. He will track their motions. He will calculate their orbits. He will name them after the Medici family. He will publish his findings. He will become famous. He will secure a position in Florence. He will live comfortably for the first time in his life, and then the Church will come for him. Tomorrow, he becomes the man who proved the universe is stranger and larger than anyone imagined. Tomorrow, he sees Jupiter's moons. Tonight, he grinds lenses and waits. The next 24 hours will rewrite the cosmos. Speed, skill, and ambition. Speed. He built his telescope in 6 months, from May to November 1609, faster than anyone else. He taught himself lens grinding. He bought artillery balls and iron bowls. He ground 60 lenses before he got a good one. Skill? He understood optics mathematically. He knew the relationship between focal length and magnification. He knew how to reduce aberration by stopping down the aperture. He knew how to test lenses by aiming at distant objects and checking sharpness. No one else had this combination of craft and calculation. Ambition, he needed money, he needed patronage. He needed to publish before his rivals. He knew Marius was building telescopes in Germany. He knew Harriot had sketched the moon in England. He knew the race was on, so he worked fast. He observed systematically. He documented everything. He wrote clearly. He printed quickly. 550 copies in 2 months. That was the difference. Galileo did not just discover Jupiter's moons. He announced them to the world before anyone else could. The technical specifications of his telescope matter. The surviving instrument at the Museo Galileo in Florence has a 37mm convex objective lens with the aperture stopped down to 15mm. The focal length is 980mm. The eyepiece is concave, 22mm in diameter with a focal length of minus 47.5mm. The magnification is 21 times. The field of view is 15 arc minutes, 1/4 the width of the moon. The tube is 973mm long, made of wood strips covered in red leather with gold tooling. It weighs roughly 1 kilogram. It has no mount. Galileo braced it against a window frame or a balcony railing. Every observation shook with his breathing. Every adjustment moved the field of view. Finding Jupiter in a 15 arc-minute field meant careful aiming and patience. Modern amateur telescopes have wider fields and steadier mounts. Galileo had neither. He had skill and persistence. Ganymede is the largest moon in the solar system, bigger than Mercury, with a diameter of 5,268 kilometers. Callisto is the second largest, 4,821 kilometers. Io is 3,643 kilometers. Europa is 3,122 kilometers. All four are easily visible through Galileo's telescope. The magnitude of Jupiter is minus 2.5. The magnitudes of the moons range from 5 to 6, meaning they are 10 to 40 times fainter than Jupiter, but still brighter than most stars. Galileo's telescope could resolve objects down to magnitude 9, so the moons were well within range. The challenge was not seeing them. The challenge was recognizing them as moons, not stars. Ganymede in 7.15 days, Callisto in 16.69 days. Over a single night, their positions shift noticeably. Io moves roughly 10 arc minutes per hour. In 2 hours of observation, Galileo could see it move. That was the key. Motion confirmed they were orbiting Jupiter, not fixed in the background. If he had not returned on January 7th, he would have missed the discovery. If the sky had been cloudy on the 7th, 8th, and 9th, he would have lost the pattern. If Marius had published first, Galileo would have been second. History turns on small things, clear skies, curiosity. Persistence. Galileo had all three. Aristotle built this model. Ptolemy refined it in the 2nd century. The Church adopted it because it placed humanity at the center of God's creation. The model had problems. Planetary retrograde motion required complicated epicycles. The moon's phases did not match the predicted brightness. But it worked well enough for navigation and astrology. It lasted 1400 years. It explained the phases of Venus, although Galileo had not yet observed them in January 1610. He would observe them later in 1610, confirming Copernicus further. But the Copernican model had a fatal flaw. If Earth moves, why does the moon stay with us? Critics said Earth cannot move because the moon would be left behind. Copernicans replied that the moon is carried along, but they had no proof, no example, no other planet with a moon. They orbit Jupiter while Jupiter orbits the sun. If Jupiter can carry moons, Earth can carry its moon. The objection collapses. Copernicus is vindicated, not proven but supported. The evidence is mounting. The Ptolemaic system is breaking. He is careful. Siderius Nuncius does not explicitly endorse Copernicus. It presents observations. It describes the moons. It suggests implications. It lets readers draw conclusions. Galileo knows the Church is watching. He knows Copernican theory is controversial. He knows he must move carefully. But privately, he is certain. The Earth moves. The sun is the center. Aristotle was wrong. Ptolemy was wrong. The heavens are not perfect. The moon has mountains. Jupiter has moons. The Milky Way is stars. The universe is larger and stranger than anyone imagined. The Church will eventually disagree. In 1616, the Inquisition will declare Copernican theory heretical. Galileo will be ordered not to hold, teach, or defend it. He will obey for 7 years. Then, in 1632, he will publish Dialogue Concerning the Two Chief World Systems, a thinly veiled defense of Copernicus. The Church will summon him to Rome. He will be tried. He will be found guilty. He will recant under threat of torture. He will spend the rest of his life under house arrest in Arcetri near Florence. He will die in 1642, blind and bitter. The Church will not formally apologize until 1992, 350 years later. Galileo is 45. He is healthy. He is ambitious. He's on the edge of the greatest discovery of his life. Tomorrow night, he will aim his telescope at Jupiter. He will see 3 stars. He will not understand immediately, but over the next 8 days, he will realize the truth. They are not stars, they are moons, and the universe will never be the same. He thinks about debts. He does not think about Jupiter. Why would he? Planets are predictable. Planets are boring. The moon is exciting. The moon has mountains. The moon will make him famous. He does not know that Jupiter will make him immortal. At 6 o'clock on the evening of January 7th, 1610, Galileo picks up his telescope. He walks to the balcony. The air is freezing. His breath steams. He aims at Orion. He sees the belt. He aims at the Pleiades. He counts stars. He aims at Jupiter. He sees the disk. He sees 3 stars. He does not understand yet. He will. History does not preserve every moment. History preserves the moments that change everything. January 7th, 1610, 6 o'clock in the evening. That is the moment. Without the grinding, the testing, the failures, the 60 discarded lenses, the cold workshop, the iron bowls, the Tripoli powder, the artillery balls, the sleepless nights, the debts, the ambition, the skill, the speed, without all of that, there is no discovery. Genius is not a flash of insight. Genius is preparation meeting opportunity. Galileo prepared for 18 years in Padua. He ground lenses for 6 months. He observed the sky for 2 months. On January 7th, opportunity arrived. He was ready. The 4 moons Galileo discovered are now called Io, Europa, Ganymede, and Callisto, names suggested by Johannes Kepler and given by Simon Marius in 1614. Galileo never used those names. He called them the Medicean stars. He numbered them 1 through 4. The names did not stick until 200 years later. Today, we know them as the Galilean moons, not the Medicean stars. History remembers the discoverer, not the patron. Europa has a subsurface ocean under an ice shell, possibly containing life. Ganymede has its own magnetic field, the only moon in the solar system with one. Callisto is heavily cratered, its surface unchanged for billions of years. NASA's Galileo spacecraft orbited Jupiter from 1995 to 2003. Studying these moons in detail, it found evidence of oceans, measured magnetic fields, mapped surfaces, and confirmed what Galileo suspected in 1610. These are worlds, not stars. The technical difficulties Galileo faced on January 6th cannot be overstated. Each lens blank cost money. German spectacle glass was expensive, roughly 1 florin per piece, half a day's wages for a skilled craftsman. Galileo ground 60 lenses. Most failed. A bubble in the glass. An uneven curve, a crack from grinding pressure, 6 successes from 60 attempts. That is the reality of innovation. Failure is expensive, success is rare. It was a scientific instrument that could reveal truths invisible to the naked eye. The moon has mountains, proven by shadows. The Milky Way is stars, proven by counts. Each answer raised new questions. Galileo did not have answers, but he had data. Data is power. Data is proof. On January 6th, he calculates costs. He has spent roughly 400 florins on telescope development since May 1609, nearly half his doubled annual salary of 1,040 florins. His debts are mounting. His brother needs support. His sisters need dowries. His children need food. The workshop rent is due. If the telescope does not pay off, he is ruined. He does not yet know it is Jupiter's moons, but he knows it is out there. O dia 6 de janeiro também é significativo pelo que Galileu não faz. Ele não anuncia seus desenhos da Lua. Ele mantém seu trabalho em segredo. Por quê? Competição. Thomas Harriot observou a Lua em julho de 1609, mas não publicou. Cautela é a morte na ciência. Publicar ou perecer. Galileu trabalhou em segredo e depois publicou rápido, sem vazamentos, sem avisos. Quando o Sidereus Nuncius chegou ao mercado em março de 1610, a descoberta era de Galileu para sempre. Suas observações começaram em 29 de dezembro de 1609, calendário juliano, o equivalente a 8 de janeiro de 1610, calendário gregoriano. Um dia após a primeira observação de Galileu, Marius publicou em 1614, 4 anos tarde demais. O mundo já dava o crédito a Galileu. Somente no século XIX os historiadores concluiriam que Marius foi um descobridor independente. Mas, a essa altura, a história já estava escrita. Galileu venceu porque publicou primeiro. Velocidade importa. Prioridade importa. Considere a linha do tempo alternativa. Se as nuvens cobrissem Pádua em 7, 8 e 9 de janeiro, Galileu perderia a descoberta. Simão Marius publica em 1611. A história acredita Marius. Galileu permanece um professor provinciano morrendo na obscuridade. Mas as nuvens não vêm. O céu está limpo. Galileu observa. Galileu descobre. Galileu publica. O clima determina a história. As estrelas eram fixas. Tudo era ordenado, hierárquico, belo. Humanos no centro, Deus acima. O telescópio de Galileu destruiu isso. A Lua tem montanhas, Júpiter tem luas. O universo é complexo, vasto, em movimento. Essas questões dividiriam a Europa. Galileu acendeu o pavio em 7 de janeiro de 1610. Ele não prevê 1616, quando a Inquisição declarará o heliocentrismo herético. Ele não prevê 1633, quando será julgado. Ele vê apenas oportunidade, fama, posição, uma vida confortável. Mas a história não se importa com intenções. Resultados importam. Em 6 de janeiro de 1610, Galileu está em sua oficina. Ele termina uma lente. Ele a testa, funciona. Ele não sabe que amanhã esta lente revelará 4 novos mundos. Ele não sabe que em 2 meses ele publicará um livro que quebra o universo. Ele não sabe que em 23 anos a igreja o colocará em julgamento. Ele não sabe que em 400 anos uma espaçonave terá o seu nome. Ele sabe apenas que está cansado, com frio e endividado. Ele vai para a cama. Amanhã é 7 de janeiro. Amanhã tudo muda.